Hi there, welcome back. This is my new restoration project. This one is slightly different from the usual in that this one came without the cabinet, and the reason is that the cabinet is a actual piece of furniture. This is a Radiogram which has the record player and cupboards for the records and everything else, and to make it simpler to do the restoration, this thing was removed from the cabinet. This is a Blaupunkt Arkansas, and this particular model, as far as I've been able to discern, is from 1963. So this one is actually probably in the right at the end of the production of tube radios from these German manufacturers. After this, they started going into transistors. Now this one is quite a special one in that it's actually stereo. It has all the bells and whistles. It's pretty well built. There are a few differences between this one and the ones I've done in the past. The first thing is that it actually has a separate power supply. It's in the cabinet, but separate from the actual chassis. The other thing is, this belongs to a friend of mine who's actually a professional restorer. Now, I don't mean one of these restorers like yours truly on YouTube that fixes these radios up. She actually restores art. So this is a challenge because whatever I do here is going to be scrutinized by someone who actually knows what she's talking about. So I better do a good job. Anyway, let's have a look at some of the details. The piano keys themselves are in perfect condition. They obviously need some cleaning, but other than that, they're in perfect condition. And if we go from left to right here, we have normal, solo, and hi-fi sonar. These will be presets for the tonal settings. We'll test them out with when the audio is being tested. Here's another one, normal or piano. Now, this will be, again, another one of the tonal presets. I'm not sure exactly what it does to the tone, but we will find out. We've got mono and stereo. Now in this particular case, mono or stereo will be for the external inputs, whether it's a phono, whether it's a tape deck, or whether it's the Bluetooth receiver coming into one of those inputs. It will allow the stereo through or convert it to mono. Then we've got the usual piano keys. This is off, aus. TA, I believe, is tape. FA is the phono player. So you choose that, or if you've got a phono player with a tape deck that records, you put the two together and you can record to the phono player, to the tape deck. Then you've got long wave, medium wave, short wave, and UKW, which is FM. Now the FM would probably, in this radio, probably go as high as 100 megahertz, possibly 104. I'm not quite sure about that, but we will find out. The reason for that is, in those days, FM did not go to 108 or whatever it is that it goes to today. On the left-hand side, you've got two knobs there and a lever at the back. The front knob is volume. The back one is stereo balance. So balance left or right if you've got this on stereo to control the balance between the left and right speaker. And then you've got a ferrite antenna rotator. And what that does is it rotates the position or the alignment of that ferrite antenna. And the reason for that is if you're listening to long wave or medium wave, those two bands would use the ferrite antenna mostly. And depending on where the transmission is coming from, you can adjust the alignment of the antenna to give you the best signal. Then down here we've also got the bass control with a little indicator behind that glass window. And we've got the Magic Eye, which I'm not sure is working on this one, but that's the Magic Eye tube in there, which will give you a tuning indicator. And on this side, we've got the accompanying treble control, again with the indicator behind the glass window. There is a stereo indication here, which would probably light up if it was working. There is a tube there. I'm not sure if that isn't working. We'll find out soon enough. And then on here you've got two tuning knobs, and the reason they're separate is that the back one is for FM, UKW, and then the front one is the one that moves the tuning condenser for the long wave, medium wave and short wave bands. So they are separate. And the FM tuner has one other function. It says here UKW, KW looper. So UKW is for FM. So that's, if it's on FM, that's what will happen. It'll tune the FM. And if it's on KW, which is shortwave, what this thing does is it serves as a fine tuning. So you'd put it on shortwave, you'd tune to a station. If it's very congested or if you want to fine tune it, you use the FM tuning. And what normally happens is this thing is connected either inside the FM can or externally. It's probably got a variable coil there. And what happens when you move this is you're actually moving a piston inside a coil, an inductor. So you're creating a variable inductance, which adjusts the oscillator frequency very, very slightly up and down to give you your tuning, your fine tuning function. But that's the front. And the glass, I haven't even mentioned it because it is in perfect condition. It needs some cleaning, some careful cleaning, so you don't get any of the writing off or the graphics off. But it is in perfect condition, which is fantastic. One thing I've noticed is that all these cords seem to be working quite well. There's an actual pulley system and dial cord going all the way through to there. And there's also some for the tuning. If we look at the back there, and if I adjust the FM dial, that seems to be working. And if I go to the AM dial, I can actually not see the capacitor turning. Okay, there's something wrong there. The pulleys and cords are all in place, but something is not rotating. So something is stuck. The tuning condenser is not moving. So that's something wrong with it. But we'll look at that a bit later. As I mentioned, the power supply is actually in a separate unit, which is plugged in to the main chassis, and everything is here. We have the selenium rectifier over there. We have some of the filtering over here. We've got the voltage selector, 120, 127, 220 and 240. The fuse, somebody has put a little wire across there, which isn't a good idea. The transformer looks like it's been a little toasty. We'll have to see if that's fine. The filter cap is on the back here, and then everything fits in. This thing is the power cord, and everything fits in through this 9-pin sort of tube type plug into a tube type socket on the actual chassis. So what we have on the chassis will have it'll be the receptacle for the B plus coming from here, the heater voltages coming from here, and probably a couple of other things like a switch function. So your AC will go in here, and it probably goes straight to there to get switched by that on-off switch, and then comes back to the power supply. But we'll have to look at the schematic and see if we can figure that out. But it's a good thing. This thing is completely autonomous, and you can actually move it around instead of having it stuck to the chassis while you're working on it. Now, looking at it from the top here, we've got the FM can at the bottom there with the ECC85 tube, which seems to be pretty normal. We have here the ferrite antenna, which I've shown you, the tuning condenser for the AM bands, the long wave, medium wave and short wave is under there, the various tubes, and everything is on a PC board. These are one of the first type of PC boards they used. So this is not really point to point. It actually makes it a little bit more difficult to swap out the necessary components. Those two tubes on there, those are actually ECL80s. They are a dual function triode and pentode. So what this does is it acts as a preamp and the power amp in one tube, and that'll be the left channel, right channel. We have here the two output transformers. Those resistors have seen quite a bit of heat, and yep, this one is not connected. That one's broken off from there. So we'll have to check that circuit and see if that's the only problem. That one is in place. volume pots and some, this is the magic eye over there. At the back here we've got that socket in the middle there is the one that comes from the power supply module. Yeah, all the coils and trimmers over there. I've got a sort of service manual which should help. I'm not sure how complete it is, but we'll see when we get to it. This is the back panel of the radiogram, which actually is quite wide, because the back of the radiogram is far wider than the actual radio chassis. It extends to the right quite a bit because it has the power supply on the right hand side and a lot of space inside basically. But this is in very, very good condition, and it gives you all the full description of what those connectors at the back will be, and I will show you them now. But first of all, as you can see, there's a type number, type Arkansas. It also has the tube layout with a full description of the tubes, which helps quite a bit. It describes a stereo adapter multiplex unit for FM stereo, which I'm not sure this thing has got, but it did have provision for it, and I'm sure somebody out there might actually have one of these. They're the two dial lamps, the tubes, the speaker connectors, and so on and so forth. Then you get to this antenna where it shows you two antennas, the external antenna and the dipole. Now the dipole is actually inside the cabinet, and what it tells you is that the dipole can be used just for FM, and you connect a particular jumper in a certain way for that, or it can be used for all bands and you connect it in a different way. And that's the jumper over there, which you'd flip one way for FM only and the other way for all bands. Then you've got the two jacks for the dipole itself, and the bottom ones are for the external long wire antenna. If we carry on here, we see a connector for a right speaker, stereo right speaker, input for a gramophone, input for a tape deck, and the output for the second external speaker, voltage selector. And also here you'll see a description of what amperage your tubes, your fuses are supposed to be. It doesn't actually mention a rusty piece of wire, but I guess that's homemade. And here we have the back end. That first one is the external speaker, right, phono input, tape input, and external speaker left. And that's all it's got at the back. Now, what we will be doing, and on this particular radio it's going to be great, we're going to be connecting a Bluetooth receiver to this. And obviously that Bluetooth receiver will be connected, whether it's internally or externally, I'm not sure yet, to either the tape input or to the phono input. Usually we connect it to the phono input, and the idea is that this thing becomes very, very useful as a Bluetooth receiver and player. But we're a little way off from that just yet. The two output transformers on this radio are incredibly important because they actually are matched to this particular tube, this ECL86. They also have a winding in here which acts as a choke for the second B+, and they also have another winding on the secondary that actually feeds the feedback circuit, which allows you to control the tone control. So these transformers are incredibly important, and there are two of them because this is stereo. So one of the first things I did obviously was to check whether they were okay or not. And the best way to do this, and I show this on a separate video on how to test output transformers safely, and I'll link that above, but I'll just do it here quickly just to show you. What we do is we connect a speaker to the output, and we connect a signal between ground and 0.6. In other words, we replace the function of this power tube by feeding a signal in here. That signal will then go through there. It will create the output through the primary, and we should hear a tone on the other side. Now, if that is working, we know we're halfway there. The next thing then would be the power transformer. But let's do this test quickly. I'll show you how that gets done. I've set the signal generator to produce a 1 kHz sine wave with an amplitude of, in this case, 1 volts RMS, and we'll activate that. I connect a speaker to the output transformer's secondaries. In other words, this is where the speakers themselves are connected, and the way they're connected, they've actually got these plugins, and that one there is ground, that one there is left and right. So we're going to try one at a time, and then I'm going to take the signal and feed it into pin 6 of the output tubes, and we should get a signal. So here's the signal coming in. It's grounded on this end, and I'm going to feed it to pin 6. That's 9876. I hear nothing. Let's try this one, 9876, and I can hear it. I'll up the voltage on the level of the sine wave to 2 volts, 3 volts. There we go. We can hear it better now. Now if I put it on this one, 9876, I have to change this up here, and there we have it. This is the output from the second output transformer. They happen to be placed on the same bracket on the top of this one, but one is from this transformer and the other one is from that transformer. So as we can see, the output transformers, at least at low voltage, seem to be working quite well. This is very promising because these two are very difficult to replace. The next step was the power supply. Now the power supply, as you see it here, is significantly different to what you saw in the earlier part of the video, because I've actually restored it completely. And the reason was I did the test and found that it was working. This is the low voltage test, the safe method, which I will link above. I have a video for that. Found that it was working. Measured the rest of the connections on this board that they have here. Replaced the fuse, which was a small piece of wire that they had on there. It says that for 220 and 240 volts output you should use a 1/2 amp fuse, so I did that. I moved that selector to 240 volts. That'll give us a slightly lower output voltage, but that's probably a good thing right now, because this thing has got a we have 230 volts mains rather than 220, so we've got 10 volts less rather than 10 volts too high. And then what I did was I checked the capacitors. Now this capacitor is a dual cap, 100 microfarads, 385 volts I believe it is. I checked them for leakage. They were leaking somewhat. The values were slightly low. I did a reforming. They seem to have reformed quite well. They may need replacing, and if they do, then I will replace them. Probably by putting it on the outside and leaving the original can there after disconnecting the top. But test will tell us whether it's producing hum or not. If not, I'm leaving it like that. I then dismantle the whole thing. One more thing, this selenium rectifier seems to be fine, because what I did was, once I'd checked the actual capacitor, I powered this up and found that it was producing all the voltages correctly. When I say correctly, they're obviously quite a bit higher because there's no load. Now the one thing I had to do is, the way this works, there's pin 1, there's pin 1, there's pin 9, and from the schematic the mains goes to there, and then it goes to the switch on the front and it comes back there. So we have 3 wires that are actually mains, a white, a yellow and a black. What we need to do to get this to provide mains is to actually switch this, and I do that with some crop clips, to replace the function of the actual switch on the front panel. And then I tested the voltages and they came out okay. They came out at about 310 volts DC. So this thing seems to be okay. The heater voltage is also coming out here. All the voltages come here. I'll show you the schematic in a second. But then what I did was I did the actual physical restoration of it. And as you can see, after cleaning the metal parts, now mind you, this is age, this is not rust, okay? You have to be careful that you don't try and actually replace something that's just a natural aging and end up creating a false restoration. And all these were redone, cleaned up, screws were de-rusted, there was some rust on the screws, and everything put back. And the result is actually quite amazing. It's as good as new. All the wires were cleaned, everything cleaned up beautifully. And we have a completed power supply module, which, as I said, if for some reason I need to replace anything on here, I can easily do that because it is separate from the radio itself. Fortunately, it plugs in with a very handy plug here. You just remove it. The other thing was, obviously, the wire was cleaned up. This is in perfect condition. This is the original cord. That was cleaned up very, very well. The one thing I had to do, I had to actually replace the plug. And the reason for that is this is a molded plug. Now, this must have been at the start of when they actually produced molded plugs. You can't open this up. But the reason I had to replace it is because this one actually shows damage on there. If you can see that, the wire's showing through. So I cut it on there, off there, and I replaced it with a period correct plug that also has, it also fits into the Portuguese system. But it's about from the same era, but this one you can open up, and it was cleaned up and it's working perfectly now. So that is what's been done so far. Our power supply is working. It's producing the right voltages. It may need to have the capacitors replaced. Time will tell. It may need to have the selenium rectifier replaced. If the voltage drop is too high, I could replace that with silicon diodes. And I've actually done a video on how to replace that. I'll link that above if you want to look at it. I'm not going to replace it just for the sake of replacing it. I prefer to test it, see if it needs replacing, and if it does, then I do that. The thing to bear in mind here, and perhaps this is more in self-defense than anything else, when you're restoring a radio like this, you're trying to keep it as original as possible. However, there are things like this which you cannot get away with. You do have to replace them. There are things like capacitors, filter capacitors, that you sometimes do have to replace because they simply don't work anymore. They've dried out. Electrolytics do tend to dry out, and you do need to replace them. Now, obviously, you do that as unobtrusively as possible to maintain the original look of the piece. And the reason I say this is in self-defense is because I mentioned it earlier, this radio belongs to a professional restorer. And this is more or less a end-of-term exam for me. I'm actually quite anxious, fearful, in fact, of how she's going to react. But I'll do my best, and hopefully she'll be happy with the result. Let me show you the schematic and show you what's been checked so far. Before going any further, I just want to point out that this thing is actually the schematic for a model called the Blaupunkt 24400. And the reason for that is the actual schematic I had for the, what I thought was for the Arkansas model, was actually not exact. And I found, as is per usual, that they use the same chassis for various radios. And this is from a desktop radio, but it uses the same chassis. And this is more accurately, at least so far, comparable to what I have on the bench here than the other schematic. So what we have here, everything that's been painted in green has been done. When I say it's been done, it's been checked. We have the mains coming in here. It actually goes to pin 9 of that socket, or rather of the plug on the unit. This whole thing here is that modular unit that I've just shown you, restored. It then goes through here, down here, through a fuse, which is the one I replaced, and it says here 0.5 amp, slow blow. That goes to one side of the transformer, the primary. The other one, the other mains connection, comes in here, goes to pin 1. Then on the socket, pin 1 goes through the switch, comes back to pin 2. Then here it comes out of pin 2, through an inductor, just a filter for high frequency filtering, in there, and to the voltage selector. Now I have put it onto 240 and we get our primary mains going in here. The output has got a low voltage output for the heaters. That goes through a quick acting link fuse, which is soldered onto that module. It goes here to pin 4 and 5, which then gets taken off at that end on the socket of the radio to the respective heater voltages, rather heater pins, and the lamps. But here what we have is the mains, the secondary coming out, the B plus, being rectified by this selenium rectifier, full bridge rectifier. One side's connected to ground, chassis ground. The other side goes to 1/2 of that filter capacitor, which I've shown you. It's 100 microfarads at 350 volts. It also then, as B plus, goes to pin 7 of that plug. That then gets taken off on that end to the respective positions of B plus. If we look at this end, we've got the B plus coming in here, goes up there, and it goes to the transformers. That's the first one. It goes to the second one as well, up here. It then goes through the primary of that output transformer to pin 6 of the power tube, the pentode part of the output tube. It also comes back through part of that winding, which acts as a choke, then goes through 2 resistors, 2.2K resistors, at the top of those transformers, and it comes to this point here, which then goes across to here, and it goes to the screen voltage to the output tubes as well, and it does the same at the bottom. What I found is that these 2 resistors were actually not in good shape. One of them was actually disconnected, as I've shown you. The tab had broken, and the other one was also, and it read very, very high compared to what it's supposed to read. It's supposed to be 2.2K. It's reading very high, so I've replaced both of them. Let me show you. And those are the 2 replacements. Now, these 2 were these guys over here. And as you can probably see, they've seen quite a bit of heat. This is all bubbly. And the readings were about 40% higher than they should be. They're supposed to be 2.2K ohms. They are supposed to be 2-watt resistors. The ones I've replaced them with are metal oxide film 3-watt resistors, 2.2K. The top of these 2 transformers, I've started some of the cleaning on here. Still got a long way to go. The cleaning is always going to be a problem with a radio like this. It is very, very difficult to get some of the grime off, but you've got to do it very, very carefully with brushes and cotton swabs and everything else, and make sure you don't do more damage than good. And you may be able to get an idea of parts of the circuit board. I've started the cleaning process over here versus the parts that I've not touched yet. We can see very clearly that it's quite a difference, but there's still a lot of cleaning to do here. And the secret is 1 millimeter at a time. I mean, you can't rush this. You've got to do this very slowly, very carefully. You've got to be careful that you don't dislodge any components, don't crack any components. You have to be careful you don't remove some of the markings on the components, because you may need to know what they are later. These capacitors, for example, these dog bones, have a tendency that if you brush them too much with isopropyl alcohol, the markings come off. Then you are in trouble. If you need to replace it, you don't really know which capacitor it is. You have to go trace the schematic all over again. So yeah, so part of the cleaning is started. Some of it is obvious, some of it is not. But I will close off this video for now. We've got the power transformers tested, actually restored. We have the output transformers in good working order, and that is great news. This radio is now, in my opinion, a viable candidate for a full restoration because the 2 main components are not damaged. Right, thanks for watching. I'll report back soon with more progress. If you like this stuff, please subscribe, click like and all that stuff. It's good for the ego, and I will see you back soon.